Hello friends, now we have assumed the Collegiate-Physics classes, lecture number 11. In this lecture series, you are welcome. Today, we will explain Einstein theory of laser emission and physical significance of Einstein coefficient. The first thing, what is laser? Laser is an abbreviated term of light wave amplification by a stimulated emission of radiation. And intense monochromatic, highly coherent and collimated beam of light is called laser light. The first theory regarding the laser emission was given by Einstein. So it is called Einstein theory of laser emission. Einstein predicted that there are two types of interaction of atoms and photons. When atoms are in the ground state and energy is given to the atoms, then the electrons of the atoms are in excited state. They absorb energy and they go to excited state. We say that the atom is excited. This is called a stimulated absorption because the atoms absorb electromagnetic energy, and due to absorption of energy, the atoms jump to the excited state. This is called only absorption or a stimulated absorption. The second phenomenon is emission. The atoms in the excited state cannot remain more than 10 to the power minus 8 seconds in their excited state. Just after it, they tend to come to the ground state, and whatever the energy they have absorbed, they emit photons with coming to ground state. That is, when atoms come from excited state to ground state, photon energy is emitted. This photon energy E2 minus E1 is equal to h nu, where nu is the frequency of emitted radiation. Besides these two types of interaction, Einstein thought that there must be some other type of interaction also. He gave the name of this interaction as a stimulated emission. There are two types of emission. The first emission is called a spontaneous emission. In a spontaneous emission, the atoms in the excited state come to ground state with the emission of photon. These photons are emitted at different states of atom at different times of atoms. So these light or these photons are not coherent. This is called a spontaneous emission. If the transition rate of a spontaneous transition is P21, then the probability of transition from second state to first state, that is from excited state to ground state, is P21. 2 represents excited state, 1 represents ground state, and this transition is spontaneous. It is equal to A21, where A21 is called Einstein coefficient. This A21 depends on the energy property of energy state E1 and the property of energy state E2. Similarly, when the energy is given to the atom, they take energy, they absorb energy, and they go to excited state from ground state. The transition probability of going to excited state from ground state is P12. 1 represents ground state, 2 represents excited state. This is equal to B12 U nu, where U nu is the intensity of incident radiation and B12 is proportionality constant. It depends on the property of ground state E1 and excited state E2. Besides these two phenomena, Einstein predicted that there must be a third phenomenon also, the interaction of photon with atoms, and this interaction is called a stimulated emission. If the atoms are in the excited state and they receive photon energy in such a condition, in such a magnitude, and in such a direction, in such a phase, that after taking the energy, the atoms jump from excited state to ground state with the emission of an additional photon. Then this is called a stimulated emission. In a stimulated emission, the transition probability P21 depends on intensity of incident radiation U nu, and it also depends on the property of ground state E1, the property of excited state E2. So B21 is also called Einstein coefficient. Now, the total emission is of two types. P21 total is equal to P21 spontaneous plus P21 stimulated. Both are added, so P21 total is equal to A21 plus B21 U nu. Now, if N1 is the number of atoms per unit volume in the energy state E1 and N2 is the number of atoms per unit volume in the energy state E2, then number of atoms in state E1 that can absorb photons and give rise to absorption per second will be equal to N1 into P12. Similarly, number of atoms going from E2 state to E1 state with the emission of photon, as spontaneous and as stimulated both, will be equal to N2 into P21. In thermal equilibrium, N1 P12 must be equal to N2 P21. In this equation, we put the value of P12 and P21, and then we get this equation. N1 into, in place of P12, we write B12 U nu is equal to N2 into, in place of P21, we write A21 plus B21 U nu. We solve this equation and we find the value of U nu equal to A21 by B21 into 1 by N1 by N2 under bracket into B12 by B21 minus 1. Now, according to Boltzmann distribution law, we know that n is equal to a e to the power minus e by kt, where n is the number of atoms per unit volume in the energy range E. A is proportionality constant, K is Boltzmann constant, T is temperature. In the ground state, the value of energy E is equal to 0. So, if E is equal to 0, then if the value of n is equal to n0, that is, in the ground state, number of atoms per unit volume is n0, then n0 will be equal to A. So, n is equal to n0 e to the power minus e by kt. This is Boltzmann distribution law. Applying this law, when the energy of ground state is E1, then the number of atoms per unit volume N1 will be equal to N0 e to the power minus E1 by kt. Similarly, the number of atoms per unit volume in the energy range E2 will be equal to N2 is equal to N0 e to the power minus E2 by kt. Let us divide this N1 by N2, we get E to the power E2 minus E1 by kt, and we know that E2 minus E1 is equal to h nu. So N1 by N2 is equal to e to the power h nu by kt, where h is the Planck's constant, nu is the frequency. Now this value of N1 by N2 is mentioned or given in equation number 14. In equation number 9, then we get U nu is equal to A21 by B21 1 by e to the power h nu by kt. This is the value of N1 by N2 here. And the rest terms are as usual, B12 by B21 minus 1. This is the formula. U nu is the intensity of incident radiation or intensity of emitted radiation. Now, according to Planck's law of radiation, U nu is equal to 8 pi h nu q by cq into 1 by e to the power h nu by kt minus 1, where h is the Planck's constant, nu is the frequency of radiation, c is the velocity of light. So these two equations are compared, and then we get A21 by B21 is equal to 8 pi h nu q by cq, and B12 by B21 is equal to 1. When we compare this equation and this equation, A21 by B21 is equal to this much, and B12 by B21 is equal to 1. Now remember, B12 is the Einstein coefficient for absorption when the atoms go from ground state to excited state. by observing radiation. And B21 is the intensity of radiation when the atoms go from excited state to ground state. Both are equal. The most important thing is here A21 by B21 is proportional to nu q, where A21 is the Einstein coefficient for a spontaneous emission and B21 is the Einstein coefficient for a stimulated emission. When frequency increases, this means A21 will increase or B21 will decrease. That is, the laser of higher frequency will be more difficult to produce. These are the physical significance of Einstein coefficient. In this way, the question is completed. The detailed note is given in this video. You may see that detailed note. Thank you for attending the class. Thank you.